Hey guys, this is the video for section 5.2, which is solving inequalities when you guys have to multiply or divide. But before we actually do the lesson or the video for the examples, I want to review with you guys how to graph an inequality, because you guys also have to graph your solution. So I'm going to show you guys a couple of inequalities here. You guys see the x is less than or equal to 5, and the one on the right side, it says -2 is less than x. You guys need to make sure that you remember what circle you need when you have a less than or equal to or a greater than or equal to. So this inequality tells you that the circle you need to put on top of this number, which is 5, is going to be a closed circle because you have the or equal to part. So on the positive 5, and I already have the number line here, it will be on top of the 5, which is a closed. One of the things that you have to remember is when the inequality is facing to the variable, inequality is pointing to the variable, the arrow of that graph is going to go to the left. So this graph is showing what numbers are actually solutions for the inequality. Any number on this side of the 5 is going to make this a true statement. If you pick the -1, it's going to be less than or equal to 5. If you pick 0, it's going to be less than or equal to 5. Any number on the left side of the 5. If you guys have a greater than or a less than with the no equal part on the bottom, the line on the bottom, that means you have an open circle. So for this inequality here, the -2 is less than x, I'm going to have an open circle at -2, and notice the inequality. The inequality is pointing to the number. So when the inequality is pointing to the number, you guys will have the arrow going to the right. And what this is saying is any number on the right side of the -2 is going to make a true statement. The 2, if you put a 2 here, -2 is less than +2, that's true. If you put a 5, -2 is less than 5, that's true. The open circle tells you that -2 doesn't work for this inequality. If you put -2 is less than -2, that's false because it's not less than, they're actually equal. So that's graphing. We are going to graph a couple of the inequalities today, but one of the things also that you have to know when you guys are solving and you are multiplying or dividing is the next bullet right here. If you guys are dividing or you guys are multiplying by a negative number when you solve an inequality, make sure to switch the inequality. So I'm going to show you guys what that means. For example, if you guys have this -2x is less than 6, to solve for x, well, we're going to have to divide by -2, just like an equation. You divide. So I'm going to divide by -2, and I'm going to divide by -2 on this side. We know this right here is going to turn into +1, -2 divided by -2. So I'm going to bring down the x, and I'm going to have to switch the inequality because I am multiplying, sorry, not multiplying, I'm dividing by a negative number, -2. So the inequality is greater than, not less than. And on the right side, it's going to be a -3. 6 divided by -2 is -3. So make sure you guys don't forget, when you divide or multiply by a negative number, you have to switch the inequality. So now let's go ahead and try some examples where you guys have to do 2 steps, 3 steps, or even 1 step to solve for the inequality. All right, so this right here is just like a 1-step inequality where you guys have to divide. So I'm just going to show you guys the first one. I'm going to give you the set notation, and plus I'm going to graph the solution. But here, it's just like an equation. I'm going to put a line under the inequality. I'm going to divide by 9. So I want that t by itself. I'm going to divide by 9. This turns into 1. So I have the t here. And on the other side, when you divide, it's 12. Now, on this one, we don't change the inequality because we're not dividing by a negative. The 9 is positive. So you guys keep the same inequality. So I have the t is less than, and we have the 12. The set notation, you just put your t is such that, and you copy down your answer. T is less than 12. For the graph, we do have an open circle. On the number line, I'm going to have 0 right here. I'm going to go all the way to +12, and I'm going to say +12 is here. I'm going to have my open circle because we don't have the or equal to part right here. There's no line on the bottom. And look at the inequality. It is pointing to the variable. So I need my arrow go to the left. So that is your graph. Okay, we have set notation and we have the graph. Now for the second one, you're going to notice we are going to divide by a negative number. So let me just zoom into the second example here. And we do want to solve and we want to graph the solution. So first of all, let's go ahead and put the border under the inequality, the line. I'm going to divide. To get x by itself, I need to divide by -6. So I do the same thing to the other side. And on the left side, a negative divided by negative, that's going to be positive. You guys cannot divide 28 by 6, but you guys can reduce the fraction. So it is going to be a positive, and I'm going to reduce by 2. So let me just show you guys here. I'm going to divide 28 by 2, and I'm going to divide the 6 by 2. So when you guys reduce by 2, we get 14 over 3. And on the right side, well, this is going to turn into 1, and we have an x here. So my answer will be 14 over 3 is greater than or equal to x. And I did change the inequality. Look at the direction of the inequality. Up here we have a less than. Down here we have a greater than because we divided by a negative number. So my set notation is going to be with the fraction. But remember that we're graphing. So it's a lot easier if you guys use mixed numbers. So I'm going to write down my mixed number here. I'm going to have for my set notation, x is such that x is less than or equal to, and I switch the order because x is on the left side when you have set notation. And my fraction 14 over 3, 3 goes into 14 4 times. So I'm going to put a 4 here. And we have 2 as a remainder over 3. Now to graph this set notation, remember, first of all, we need the number line. So we have right here. I'm going to have the 0 here. And I'm just going to use the units of 1 so you guys can see where the number 4 and 2/3 should be. So here's the positive 4 and here's the positive 5. Now 4 and 2/3 is going to be obviously more than 4. And 2/3 is a little bit more than 1/2. Is in decimal form is 0.66666. So more than 0.5, more than 1/2. So I'm going to say that right here is 4 and 2/3. My circle needs to be closed because we have the or equal to, and the arrow has to go to the left because the inequality, it is pointing to the variable. So the arrow goes to the left. All right, let's try a few more examples. And this is when you guys have to multiply to get the variable by itself. So let's go ahead and look at this one. We're going to solve. I'm not going to graph these ones, but I'm just going to show you guys how to solve the inequality. So for the first one, we have a fraction and the denominator is 11. To get rid of the fractions, you multiply by the denominator. So I'm going to multiply this side by 11. I'm going to multiply this side by 11. So let me just put the border, the line here so we know what side we're looking at. So the left side, we're going to get a negative 121 when you multiply 11 times negative 11. On the right side, be careful. We do have a negative c. So when you multiply negative c times 11, that's going to be negative 11c. And you keep the denominator. Do not multiply 11 times 11 again. You multiply the top and you keep the denominator. Now, you guys can reduce. This right here, negative 11 divided by 11, that's negative 1. So we get negative 121 on the left side, negative 1c on the right side. Now we do have to solve for c. So I'm going to divide by negative 1. And you divide the other side by negative 1. So you guys will have a positive 121 because negative divided by negative is positive 121. You have to switch the inequality because we are dividing by a negative number. So up here we have a greater than, down here we're going to have a less than, because you switch the inequality. And on this side, this turns into 1, so we just have the C. Now for your set notation, remember you have the C on the left side. So I'm going to have C is such that C is greater than 121. So here's my answer. Let's try another one with the fraction. Look at the one on the right side here. We have a fraction, denominator is 3, so I will multiply by 3. So let me multiply this by 3, the other side by 3. So on the left side, let me just put the line here. You multiply the top, 3 times 2 is 6. Keep the denominator and bring down the variable. So 6 over 3h. On the right side, 14 times 3 is 42. You guys divide the fraction. 6 divided by 3, that's 2h. And on the other side, we have a 42. Let me just bring down the line here. I am going to divide by 2. So I will have h is greater than, I don't switch the inequality. Notice the inequality is greater, so I keep the greater because I am not dividing by a negative. This 2 is positive. And on the other side, when you divide 42 divided by 2, that'll be 21. So my set notation will be h is such that h is greater than 21. So here's my answer. Also guys, it's very important that you understand the phrases for inequalities, because when you have a sentence, you have to learn how to change it to an inequality, from a sentence to an actual inequality when you guys have specific phrases. So look at the screen. You guys have 4 different inequalities. Each phrase represents an inequality. You guys can read the inequality here. You guys can read all this and here. The only thing that you guys have to look for is what phrase you have in the sentence, and that's the inequality that you guys are going to use. So make sure that you guys read them. Make sure that you guys know which one it represents. So let's try an example. We want to write these sentences into an inequality. So let's just read the one on the top, the first bullet. It says -3 times a number is no less than 8. So we have to know what is no less than, and we have to convert that into an inequality. So let's underline some keywords. So it says -3. So I'm going to put -3 times a number. So I'm going to put x for my number. Is no less than. That keyword or that key phrase, no less than, means greater than or equal to. And I want you guys to go back to the video. Look at the phrases. No less than means greater than or equal to. So I'm going to put the greater than or equal to here, and is greater than or equal to no less than 8. So I put in 8 right there. I'm not going to solve. You guys already know how to solve. You've seen that. But the inequality that we're looking at is this one here. -3 times a number is no less than 8. Now let's try the next one. The next one says 5 times a number. So I'm going to have 5x is at most. So we have to understand what is at most. So at most means less than or equal to, and we have a 10. So I'm going to put less than or equal to and 10 right here. So like I said, guys, I'm not going to solve the inequality. You guys can do that, but that is the inequality from a sentence. 5 times a number is at most 10 is translated to an inequality. 5x is less than or equal to 10. All right, guys, so this is the video for section 5.2, which is inequalities. Make sure you guys practice, and I'll see you guys later.